Hello students. Now we will see tangential and normal components. This is important bit in our syllabus. Okay, so see this sketch here. This is the path of a particle. Okay, at any instant the particle is here. Okay, and its velocity is along the tangent to to the curve. Okay, so this is acceleration at an. Okay, acceleration is directed like this, x and y coordinates, origin. Now see, velocity of a particle is always directed along tangent to the path of a particle. Okay, we know this is we know, but acceleration is not along the tangent to the path. Okay, so the tangent is like this, so velocity will be in this direction only, but the acceleration is not always in this direction, it could be in some other direction. So this is it. So most useful component of acceleration are along the tangent and along the normal to the path. Okay, and these two components separate the rate of change of magnitude and direction of velocity. Okay, so this is the acceleration. It has got two components, one along the tangent, one along the normal. This tangent component is at. Okay, this component is an. T cap is unit vector along this at direction, n cap is unit vector along this an direction. Note at and an are mutually perpendicular to each other. Okay, and a is composed of this both at and an. Okay, so tangential component, it gives us rate of change of magnitude of velocity. Okay, rate of change of magnitude of velocity. And normal component an, that gives rate of change of direction of velocity. We know velocity is a vector quantity, so it has got both direction as well as magnitude. So if magnitude changes, that will be reflected into at, and if direction changes, that will be reflected into an. Okay, see this diagram carefully, we will be requiring this in further discussion. Okay, let t cap be the unit vector along tangent, as I told you already. So v bar is equals to v dot t cap. So v bar is equals to v magnitude into t cap. Okay, so mod of v bar is equals to v is equals to ds by dt. Okay, so a bar dv bar by dt. So we know d by dt of v into t cap, this we have substituted. So so now this v into t cap, okay, product of two variables. So u into v formula, dv by dt as it is, differentiation of first, into second as it is, t cap as it is, plus first v as it is, dt cap by dt. Okay, so call this as equation number 1. Okay, now so we can write dt cap upon dt is equals to dt cap upon dt d psi into d psi by ds into ds by dt. Purposely we have introduced psi here. Okay, and this s ds here. Okay, d psi and ds we have already introduced it purposely. What is the purpose, we will see, come to know later. Now d psi by ds is equals to 1 by rho, where rho is radius of curvature at that point and psi is the angle made by tangent with the x-axis. Okay, so if this tangent is extended backwards, it makes an angle psi with x-axis. So the d psi by ds is equals to 1 by rho. Okay, don't worry, we will derive this d psi by ds is equals to 1 by rho also later on, but now we will use this as it is. Next, so a bar is equals to dv by dt into t cap plus v square by rho into dt cap by d psi. So how does this has came? We know a bar is equals to we know a bar is equals to this dv by dt into t cap plus v in v dot dt cap by dt. Okay, so instead of uh, ds by d psi by ds, we have replaced 1 by rho, and this has come now dv by dt into t cap plus v square by rho into dt cap by d psi. So name this as equation number 2. Now what is dt cap by d psi? Okay, let us see this in detail. So this is the diagram, x and y axis. This is the curve. Okay, 2 points p and p dash on the curve. Okay, at point p, this is the tangent. Okay, so t cap is unit vector along that. Okay, at p dash, this is the tangent. T cap plus del t cap, okay, delta t cap is the unit vector along this direction. Okay, and this tangent at p makes an angle psi with x-axis, and tangent at p dash makes an angle psi plus del psi or delta psi with x-axis. Okay, let p and p dash be the two consecutive positions of the particle at time t and t plus delta t. Let t cap and t cap plus delta t cap be the unit vectors at p and p dash. Okay, next let psi and psi plus delta psi be the angles made by tangent vectors at p and p dash. Okay, so that now delta psi is the angle between tangent vectors. Okay, so here the angle formed is delta psi. Okay, now to evaluate that delta psi, see here. Now through point A, draw two vectors parallel to and equal to t cap and t cap plus delta t cap. Okay, so this is point A, so t cap vector and t cap plus delta t cap, making an angle delta psi in between them. This has been drawn. Okay, next complete the circle as A as center. Okay, so as A, complete the circle. Now see here. So this is point A1 and this is A2. Okay, and this chord length is uh, delta S, and this A1 A2 is delta T cap. Okay, so length of A1 A2 is delta T cap, and let chord or arc length, not chord, it should be arc length A1 A2 is equals to delta S. Now by definition, delta t cap upon del psi, oh sorry, d t cap upon d psi is equals to limit as delta psi tends to 0, delta t cap upon delta psi. This is the definition of this differentiation or limit definition. Now as del psi tends to 0, this del psi tends to 0, delta t cap becomes arc a1 a2. Now you can see here, when this delta psi angle becomes smaller and smaller, this a1 a2 coincides with arc length a1 a2. Okay, so now arc upon radius is del psi. Okay, but we know its radius is 1, so arc a1 a2 is equals to del psi. Okay, so replacing it, limit delta psi tends to 0, uh, mod of delta t cap upon del psi is equals to 1. Okay, so as delta psi tends to 0, delta t cap acts along tangent at a1 and hence perpendicular to t cap. So let us see, as delta psi tends to 0, delta t cap acts along tangent at a1. Is it true? So when del psi tends to 0, okay, so uh, delta t, this is tangent at a1. Okay, yes, that's true. Hence in limiting position, delta t cap acts along the normal. Delta t cap acts along the normal. Okay, so thus delta dt cap upon d psi is equals to limit of delta psi tends to 0, delta t cap upon del t cap upon del psi. Hence, so its magnitude is equals to 1 and acts along the normal. So dt cap upon d psi is equals to n bar. Okay, so putting these values in equation number 2 earlier, we get a bar is equals to dv upon dt into t cap plus v square by rho into n cap. Okay, so this was about the derivation of uh, formula for acceleration. Okay, this gives nothing but the acceleration. Okay, so dv by dt into t cap plus v square by rho into n cap. So this is normal component of acceleration, this is tangential component of acceleration.